Hi everyone, I'm Mike Cook. I am one of the authors of this paper, and I was supposed to be there in person to talk to you today and enjoy the conference with you, but unfortunately there was an emergency and I missed my flight. I really hope you're having a wonderful conference, and I'm really sorry about this, but at least I'm managing to talk to you remotely. Today I want to talk to you about framing. This is work I did with Simon, Alison, and Teresa over many years, lots of discussions, lots of projects, lots of thoughts. And really this paper is to try and collect lots of ideas about framing in one place and hopefully make it more accessible to people. So I'm hoping that this talk will also try and do that as well. So first I'm going to tell you what it is, because one of the problems that we identify in the paper is that lots of people probably don't know what it is. And we're then going to try and break down different ways to think about this new concept of framing, ways that you can practically start putting it in your software, which I hope you will do. And then talk a little bit about the future of the field as well, and it's going to be good. I'm not going to go over the paper in excruciating detail. Different sections we're going to kind of dip into and out of, but please go and look at the paper. I think it's pretty readable, I think it's pretty clear, and I hope you'll enjoy it. So I wanted to start by talking to you about two quotes. The first is by my PhD supervisor, Simon Colton, who is a familiar face at ICCC, but not actually here this year. Something he used to say was that software has to work twice as hard as humans to be perceived as creative. And this was something which affected me a lot when I was a PhD student, and it's influenced a lot of the way I think about building creative software. And another thing which also had a big impact on me is a paper Simon wrote with Geraint Wiggins, who probably is in the room. Hello, Geraint. Which they kind of wrote a definition of the field of computational creativity. And they described it as the science, philosophy, and engineering of computational systems which exhibit behaviors that unbiased observers would deem to be creative. And this was so interesting to me and really important, because it didn't talk about what the software did or how fast it was or how good it was. It talked about what other people thought about it, this external evaluation function. And I think these two ideas are very important, and I think they influence a lot of our thinking about framing. They certainly influenced a lot of mine. So framing is kind of introduced to computational creativity in a few papers in 2011, and one in particular proposes what's called the face model, and it was supposed to be a way of formally describing a computationally creative system and what it did. And the idea was that each letter in the face model represented a different part of a creative system, a different act that a creative system could perform, like evaluating something or creating the concept of something. And it was a little bit complicated, but it was pretty cool. It was pretty interesting. And the F in that system stood for framing, and that was the thing I was most interested in. And the way that framing is described in that paper is a piece of natural language text that is comprehensible by people, which refers to a non-empty subset of generative acts. So by generative acts, they mean things in the face model, so things like evaluating something, creating something, even framing. You could frame framing if you wanted to. And this definition is a little bit wordy, which is something we'll mention later. But I was really interested in it. And the analogy that kind of hammered it home to me eventually was that framing is not actually anything to do with the frame on a gallery, on a piece of artwork. It's actually referring to the piece of text that is next to the artwork. The thing that tells you who painted it, when they painted it, where they lived, what background they had, who paid them to do it. All of this extra information that helps you appreciate and understand a work of art. So framing was very important to me when I was doing my research, and one of the motivations, at least for me, for writing this paper, is that I just wanted to talk about it. I just wanted to talk about how useful it had been to me and how exciting I found it, and talk about all these different ideas. And as part of this, what we wanted to do was we thought, well, I'll survey the last few years of ICCC and look at, how did other people use framing? And then we can talk about the different approaches, and that'll be really interesting. And then we did the survey, and what we found was that almost no one uses framing. If you actually look back at the last few years, you'll find that there's a very, very small number of systems papers which frame their work. And if you restrict this to papers which explicitly mention framing, it's even less. So there are some systems which do frame their work but don't actually use the term, they don't cite any of the papers. but there's lots more that just don't do it at all. And this was really surprising, and it kind of took the legs out from under me, sort of, in terms of what I'd intended to write for my bit of the paper, and it was very surprising. So why? Why don't people use framing? Well, we put forward a few ideas in the paper. Obviously, there will be many more reasons than this. One is understanding. So as we described, the definition of framing is quite formal, it's a little bit dense, and if you're just coming to this, the face model is quite overwhelming. So maybe a lot of people just stop there. Even if you understand what framing is, it's not clear kind of how you add it to a system, and or what good framing even is, or what simple framing is. And so probably there's a sense of not knowing where to start for some people. And also, very few papers exist, although ironically I think there is one at this conference, that actually look at whether framing does anything. So there are lots of systems that use framing, but many of them just sort of acknowledge that it exists. There's some anecdotal evidence, but there's no kind of hard and fast data. And I think for many people in a community like this, everyone has a different outlook on what computational creativity is. And as a result, many of our personal philosophies, they don't really kind of gel with framing, maybe. It just doesn't seem important, and that's fine. But we wanted to try and write a paper that would maybe help with some of these issues, maybe help people who wanted to use framing to kind of build it. So one of the first things we did was in the paper is we introduce an alternative definition of framing. Now, this definition is also wordy in its own way, but it doesn't reference anything as complex as the face model. It can kind of stand on its own, which is useful. And it also extends it in some important ways as well. So, framing refers to anything created by software with the purpose of altering an audience's perception of a creative work or its creator. So there's three important things I want to point out about this new definition. The first is that we no longer mention text. So framing can now be anything. It can be another artwork, it can be visual, audio, it can be all kinds of stuff. And I think that's really important. There are many different kinds of framing, and certainly in video games we see lots of framing which is non-textual. The other thing is that we actually explicitly mention the audience, we explicitly mention perception, and this ties it in a little tighter with that definition of computational creativity that we mentioned earlier, Geraint and Simon's definition. And I think this is important because it focuses what framing is actually intending to do. It has a much clearer goal now. And finally, we say we don't kind of restrict framing to only talking about a creative work. It can actually frame the system itself, not just the things the system produces. And this is really important for something that I call presence, which we will bring up briefly later on in the talk, I think. We mention it in the paper anyway. But the idea is that it's important that framing can also establish this software, this system, on its own, not just in terms of what it creates, but the system itself growing, developing over time. Now, it's important to know that we're not trying to replace the old definition of framing. We think that it's just as useful. The face model is really cool, but we just wanted to produce like a different angle for people who maybe were put off by it in the past and wanted a different way of thinking about it. And we really like this definition. So for the next bit of the talk, I wanted to step you through kind of the meat of the paper. And the aim here was to kind of take people on a step-by-step process of you're sitting down, you're going to build a new computationally creative system. How would you build framing into it? What are the steps you'd need to go through? What questions would you need to ask yourself? Now, we're not going to go through every single bullet point in the paper. I've just picked a couple out from each section. But if you're interested, the paper is fairly well structured, I think, and it's quite easy to skip to bits that you're interested in. So we broke it down into sort of 4 questions, and we'll start with why. So before we actually do anything, what goal are we setting ourselves for the use of framing in this system? So there's many different examples of framing being used for different things, and I apologize in advance. The paper has many different examples from different systems. A lot of the ones I've used in this talk are about systems I'm intimately familiar with, like the Painting Fool and Angelina, my own system, and Simon's system. So a key example, a key use of framing is clarification. So this is information that the audience does not necessarily need to appreciate something, but it might enhance their enjoyment of it. So the Painting Fool, which is Simon Colton's AI artist, also creates poetry, and you can enjoy its poetry without knowing anything about how it was made. But if you also know that the poem was made based on a newspaper article about Thailand, then that might enhance your understanding of it. It's sort of like a bonus. It's not necessary, but it adds extra stuff in. This is a very, very common use of framing. Arguably, all framing does this in some way. A related but distinct reason is reassurance. So in many examples in Angelina's video games, people would notice things about the game, like the fact that this person on the left here looks a little bit angry, and they would wonder whether this was intentional or not. Because, remember what we talked about at the beginning, software has to work twice as hard to be accepted as creative. Because people tend to assume that things software do is kind of random or undirected or derived from someone else, we found that it was really important with Angelina, this game designer, to have it explicitly talk about decisions it's made so that people almost viewed it as a kind of a two-factor authentication. So they would see something in the video game, they would wonder whether this was intentional, and then they would see it referenced somewhere else in the framing information, and that would kind of confirm to them that yes, this was meant to be there, this was there for a reason. Another really useful purpose of framing, just one more for this section, is mitigating criticism. So people love to criticize AI when they're acting creatively, and one of the great things is that if the AI is able to get out ahead of that, they can actually deflect it or reduce the impact of the criticism. So when the painting Fool sits people down for portraits, it actually tells people what it was trying to achieve with its portrait and shows them an image, kind of an example of what it wanted to achieve. And then it shows what it actually did and whether it was happy with it. And so it's really hard to criticize the software for, it said it wanted to produce a realistic portrait, and this one isn't realistic at all. If the system's already told you that it feels like it failed, then it's already kind of engaging you in better faith than you are. It's kind of showing you, yes, like I already know that this wasn't one of my best. And this is a really, really useful way of swinging people around to your side, is to show that you are aware of, the software is aware of its own weaknesses or shortcomings, for instance. So if you know what kind of goals you want for your framing, what things you want to use framing for, then you need to look at what data is available to me, what information can I use, what about the system that I've built could be repurposed or discussed in framing information. So a really common one that people love, it's really interesting to people, is if your system uses internal evaluations for something, you can use those evaluations to talk about other things later down the line in framing information. So if your system evaluates paintings while it is painting them, then that means that it could also evaluate paintings that it's never seen before, it could evaluate other things that it's done, it could compare paintings. So you can use this evaluation as a source of information in your framing. So this is really, really useful. Another nice one that really strengthens any discussion of an artwork or a creative work is if the system was asked to do something, if they were given a request or a specification or a commission, then being able to talk about that, being able to talk about what was asked of them, can really enhance the people's appreciation of what they've done. So for instance, Sonancia is a system which designs soundscapes and kind of atmospheric settings for video games. And if you tell it, oh, I want you to create a level that has a cliffhanger, that is kind of rising tension with a release, then it can actually show people not just the level it created, but also point out, by the way, I was asked to create a cliffhanger. So this is, again, allowing people to relate and reassure themselves that this is what was requested and this is what the system did. So it didn't just decide to build a cliffhanger ending. This didn't come about by chance. It aimed to do it. It understood a request and aimed to do it. So that's very powerful. So you know what you want to do with your framing, and you know the kind of raw data you have available to you. But there's this other really important thing that you need to assess, which is what actually does your system do? What are the processes in your system? And what do they make easier to frame, and what do they make harder to frame? And in the paper, we call these algorithmic affordances. And I really like this notion, and I really want people to think about it more with respect to framing. Because choosing an algorithm or an approach or a process is kind of like choosing an artistic medium to work in. They achieve different things, they have different strengths, different weaknesses, and unless you are planning to just outright lie to your audience, which is totally valid, and we'll talk about that later, you have to be able to support the framing you want to do through your algorithm. So for instance, if you want to talk about failures, if you want to show people examples of things that your system did wrong, then your system needs to have examples of failures. It needs to be a generate and test system, for example. If your system is constructive and it never produces a bad output, it just continually adds things to something until it produces something good, it can't talk about failures or dead ends because it never experienced any. Again, unless you plan to lie about it, which is obviously a different approach. So what I want to kind of, we give some examples in the papers. For instance, we break down, what does computational evolution afford us? What does neural nets afford us? But I really want to get this idea that choosing an algorithm or choosing an approach for building a system, it's not just about efficiency, it's not just about optimization or power or what we're comfortable with. Another thing that we should be considering alongside all of these factors is what story is this going to allow the system to tell? What framing is going to be available as a result of these engineering decisions I'm mentioning now? Because the two things are intricately linked. Okay. So the final bit is in what form should this framing come out? So at the beginning, we talked about how framing was actually just text. It was natural language, words on a page, and the idea was that it was kind of like the text you saw next to a painting on a wall. But there's many different ways in which framing can manifest, and we talk about a bunch of different ones in the paper. A couple that I wanted to talk about. One is visual analogy. So when the painting full paints a portrait, you actually see a hand holding a brush running across the screen, and it touches the canvas everywhere a new brushstroke is painted. And this is really impactful because it draws the attention of the user so that they can see new lines being added. That allows them to appreciate the details being built up over time, and it allows them to kind of understand the way in which the system is building this image. So this is a very important kind of framing. Another example we saw last year at ICCC is diegetic framing. So last year we had a paper presented that talked about customer service agents that were able to just improve the customer's experience of calling up this helpline, for instance. And in their examples, they show how their hypothetical system, they didn't actually build this, but their hypothetical system was framing the things that it had done, but it was doing this framing in character. It was talking about it was doing the framing kind of in the world that it had created to be creative within. So this is something which is very common in video games, and it's actually very common in AI systems. And so this is, I think, a really interesting way of framing. We use the term diegetic just to mean it's kind of embedded in the fiction of what it is doing, or embedded in the work itself. And I know that lots of this stuff can feel gimmicky. The whole process of framing can feel gimmicky, in fact. But I really think that, in particular, the way in which we frame stuff, not just always choosing text because it's easiest, but actually thinking what is the most appropriate form this framing should take, I think that's really important because it really changes the impact of a framing story. It changes the impact of a message. So if I tell you, for instance, that in major animated movies, animators often use footage of people acting stuff out as references for their own work, that's an interesting story. But I could also just show you this video with absolutely no text whatsoever. So this is Emma Shi, who is an animator on Into the Spider-Verse, and these are reference videos of Emma acting out various roles with the dialogue. And you can see here in particular, they acted out in 3 different ways, 3 different takes, so that they have 3 different references for their animation. And it's extremely powerful. And this alone, with no text, no words, no explanation really, other than the knowledge that Emma is an animator on the film, that's just enough. And it's super powerful. It tells you a lot about the creative process. It's engaging, and it's funny. And this is the kind of decisions we need to be thinking about, is how should our software tell its stories? So these are the 4 questions that kind of we try and step you through in the paper, kind of like a process for thinking about end-to-end framing in your system. Before I finish, I know I'm running at the end, but bear with me. Just a few slides, some points that we bring up in the paper. So the first is this idea of lying to people. So we talk a lot both in papers, in lectures, informally, discussions in the evening at conferences like ICCC, about the idea of fictional framing, lying to people. But as far as I know, very few systems have ever dabbled with this. And so we do eventually, I think, need to study this. Like, does it work? How easy is it? Is it actually any easier? Because really lying is potentially more effort than just regularly telling people what you did. There is evidence that people really don't like being deceived either by AI or by humans about AI. But these are usually in fairly serious contexts like the care of children or life-threatening incidents. We imagine that in non-serious, fun, creative contexts that people will be more willing to play along and might not mind it as much. But again, we don't know. So someone needs to ask these questions. Another thing that we mentioned in future work is the idea of framing first systems. So these are systems which do not create, artworks or video games or things like that. But in a sense, their creative output is framing. They look at work created by other people or other systems, and they produce some kind of framing about it. So one way in which we are looking into this is that we are kind of planning to build what we're calling an AI festival for building bots that critique or review or curate or discuss interactive fiction. So this is a screenshot from an interactive fiction game where it's essentially a text-based game, usually tells a story. There's some simulation elements in there as well. And so the idea is that people will write AI systems that play these games, look at the text, understand the game, and try and say something about it, or curate it, provide feedback, review it. So the idea is that these systems are going to be framing. They are going to be designed purely to frame the work created by other people. So what the systems that do that look like? I think that's a really exciting thing to look at. Okay, how do you describe this field to other people? Your family, friends, people who work in other fields, co-workers from further afield. Maybe you give them quite a formal definition. Maybe you give them something more informal. Maybe you reference the current state of AI. We kind of express a concern, I guess, in the paper that the AI boom has maybe passed us by. We didn't notice a meteoric growth as other conferences and workshops have. We're growing steadily, and it's amazing to welcome new people here every year, of course. And this is our 10th ICCC, which is an amazing milestone. But it's definitely clear that a lot of the things that we thought the public and press and industry would be interested in and would care about, they perhaps don't care about it as much as we thought. Maybe this is a cynical view, I don't know, maybe you disagree with me. But I think I certainly am concerned that we are losing relevance. And for me, framing is an opportunity to kind of leapfrog the current frontier of AI and find new space, new territory, new questions, new spaces to explore and invite people into. I think it's one of the purest kind of definitions of our field, one of the purest instantiations of something that we can do. And I think the future of computational creativity is about transforming how people create and also changing their relationship with creative software, especially computationally creative software. And I think that requires framing. And to me, I think that's a really important future for the identity of this field. And I don't know how you feel about that, but I would love you to read the paper and let all of us know how you feel about it. If you want to contact any of us, here are all of the author email addresses. I'm also on Twitter at MTRC if you want to fling me a quick question on Twitter in the coffee break or after today. Thank you so much for listening. I hope this has been interesting. I hope you enjoy the paper as well. I'm really sorry I couldn't be with you all, but hopefully I will see you all in next year's ICCC. Thanks for listening.